talking about linear equations and ordered pairs. And it's kind of interesting to see that linear equations appear in many real life situations. For example, a lot of times we have monthly payments, or there might be a startup fee with additional uh, dues for certain things like text messages, or maybe if you rent a car, you have a fee plus so many miles. So maybe let's say we rented a car and there was a fee of $15 plus $4 per mile, let's say. Well, we can make an equation that says our payment is going to be $15 plus $4 per mile. I can use P for payment and M for mile and maybe make an equation that looks something like this. You notice that there are two variables. Depending on how many miles I go will depend on my payment. I have two different variables that are going to change depending on what happens. This is going to end up, if I were to graph it, looking like a line. Anytime I have two variables, we have a linear equation. So let's look at an idea, an example that might have to deal with a real life application graphing a line. So it says here in example number 5, the value of V of a shopkeeper's inventory software program in hundreds of dollars is given by this. So V equals negative 3/4 T plus 6. So V is the value of the software program, where T is the number of years since the shopkeeper first bought the program. So T is time and V is value. Graph the equation and use the graph to estimate what the program is worth 4 years after it was first purchased. So you notice that we have this equation with two different variables. Depending on how long I keep it will depend on the value of my program. So my t happens to be what we call our independent variable. That usually goes along the x-axis. So my t, or x, is years. Depending on what time we keep this program for, how long we keep it for, will depend on the value of the program. That's my dependent variable, or my y value. So they use different letters, different variables to mean a little bit more with our word problem, but you can always change those into y's and x's if it makes you feel more comfortable. But also try to use t's and v's and other types of variables so you're not too stuck on x's and y's. So on this one, we have t's and v's, x's and y's, right? T is our years, v is our value. We can figure out what this equation looks like by graphing it, by finding ordered pairs that work. We can find t values, pick t values, and find our v values, our x values and y values, right? So doing the same thing that we did in the previous example, last video, we picked certain t values and found the v that went with it, or picked a v value and found the t that went with it. Finding a bunch of ordered pairs that work will tell us what our graph's going to look like. So I'm going to pick some t values, some years. Let's start off easy. Let's do 0. If I plug in 0 into my t, I'm going to do this here. If I plug in 0 for t, 3/4 times 0 is 0, right? And 0 plus 6 is 6. So I end up having an ordered pair at 0, 6. Let's try another t value. Now, we might have to strategize a little bit because we have this fraction. So we need to think about what number can we plug in here so that hopefully we'll end up with nice whole numbers so it'll be easier for us to graph. Well, if you think about it, anything that's divisible by 4 will help us get rid of that denominator. So let's choose a number divisible by 4. Let's choose 4. So if I plug in 4, I end up with negative 12 over 4, which is negative 3, and negative 3 plus 6, which is 3. So I have an ordered pair at 4, 3. What that means is if I keep this program for 4 years, it's going to end up being worth $300, right? All right, let's do a couple more if we want to make sure that our line is a little bit straight. It looks like the next one I chose was 8. You can plug in an 8 and figure out what the y coordinate is. I ended up getting 0. What that means is if I keep this software program for 8 years, how much is it going to be worth? Oh, 0, right? Eventually, it's going to lose its value. So the equation should kind of make sense, right? Over time, doesn't normally technology lose its value? Okay, well, when I go to graph these ordered pairs, I have 0, 6, over nothing, up 6, 4, 3, which is right for up 3, and I have 8, 0. Wah, wah. So I can connect these, and really I probably shouldn't be going over to the left at all. Because that means time. And then you're telling me that time is negative. So you have a time machine also, right? Doesn't quite make any sense. So my line probably is a cutoff line that only goes in one direction. Now, also, we might not want to go below the x-axis because that would mean that our value is negative. I don't know if that's necessarily the case in this problem, but you get the point, right? All right, well, can we use this line then to estimate what we think the value is going to be after 4 years? So if we couldn't necessarily plug in values, could we still use the graph to figure out approximately how much the software was going to be worth? Well, remember, the x-axis is the time in years. And so if I'm looking for 4 years, I'm looking for t equals 4 or x equals 4. I should be able to follow it up and figure out what y value matches, or at least estimate what it is when t is 4. And so I don't know about you, but it looks like it kind of corresponds to somewhere around 3. And not just $3, but remember, $300 from the word problem. So if I keep this program for 4 years, then the program is going to be worth approximately $300. Now, you could have gotten that by actually plugging in like we did, or if you didn't necessarily pick 4 as one of your years, maybe you picked 8 and 12 and something like that. But you could still use the line, the graph, to estimate what the value is going to be after 4 years.